In this next lesson, we're going to look at traits, and I'm going to primarily focus in this lesson on using traits as pure interfaces. And as a quick introduction to traits, in their most simple use, what we're going to do in this lesson, traits are used as pure interfaces, and that means we only define abstract methods in those traits, and then those methods will later be defined in the classes that implement our traits. And actually, down here, we say that traits are mixed into classes and objects. So we don't necessarily say that traits extend classes so much as we say that they're mixed into those. And we'll see what that means in this lesson and the lessons that follow. In addition to traits having methods, they can also have fields. So inside of classes and traits and objects, we say that these things are members. So members is just a term that we use for fields and methods inside of these. And methods can be abstract or concrete. Abstract means they don't have a body, and concrete means they do have a defined body or a defined behavior. And coming back here, an interface, and I probably should have written here, a pure interface, is a construct that has only abstract members. So as I note in this paragraph over here, if you imagine an animal that has a tail, something like a dog or a cat or any other animal that has a tail, the way I think about this is I start to write a trait. So I say, well, I'm going to create a trait, and it could be named something different, but I call this one has tail. And then I start to define the methods that define the behaviors for something that has a tail. So here I have this one called start tail, and this other one's called stop tail. And the key about these guys is that they don't have any implemented behavior. So if you notice over here on the right side, there is no equal sign followed by a body. And I think I showed that, yeah. So I showed that down here in the class. When you go ahead and implement these, you will implement a body over here. But when you use a trait as a pure interface, you just define the method signatures like this and like this. And one other thing that's worth mentioning is that methods that you define can also take input parameters. And these two just happen not to take any input parameters. But if you did, you would just list them inside the parentheses here, just like any other method. And as I go on in this lesson, the next thing I note is that if you think about a dog or a cat, another behavior it has is that it can speak. So here I define a trait called can speak. And again, it has an abstract method, and this one is named speak. And down here, I start to show how to implement this. Well, let's go ahead and look at how to do that in a file, and then we'll create something that we can run at the command line. Okay, so what I did here is I pasted these two traits in. And now what you can do is start defining a class. So I want to create a dog class. So I say class, dog, and then we say extends these traits. So I'm going to say extends has tail and can speak. And one thing to point out here is that if dog extended more traits, you would extend them here, and you just keep separating them by commas. You may say has fur, rubbery tongue, and so on. So you just keep separating those by commas. But we only have these two, so then you put the colon there to indicate that we're going to start the definition of the class body. And now what I need to do inside this area here, inside the class, is I need to implement these methods because they are abstract here. So I will copy those, paste that one there, copy this one, paste it here, scoot that over. And now we need to implement the body here. So I will just say, so each of these are going to be print line. I will do that and that. So start tail, I would say tail is started. And this one, tail is stopped. And dog would say something like woof. And that's all we do for that. So if you haven't done this before, this is actually very common in object-oriented programming, is to define interfaces like this that have abstract methods. And these methods here define the potential behaviors for the trait or interface. So these methods define the behaviors for a tail, and then this one defines the behaviors for something that can speak. And just to reiterate a point that I mentioned earlier, if you wanted this speaker to be able to say something here, then you would add a parameter here, such as a string. And I just wanted to show that's how you add parameters, and that's one parameter. And then if you wanted to have another parameter here, you could say something like language, string, and so on. So I'm just trying to demonstrate that these methods can have input parameters just like any other method. But getting back to our class, now that we have that defined, we can create a main method to run this. So I'll say at main def Now I'll just call this traits, give it a name, and what I'll do is val d equals dog. And one thing to note here is that the dog constructor doesn't take any input parameters, and that's because I haven't defined any class constructor parameters here. So if I happen to have something like this where I want to give a dog a name, I would do that, and then I would have to supply the name down here. But since I don't have this, this is how we create a dog right there. Now that I have that dog, I can call these methods on it. So I could say speak, and I could say start tail, and I could say stop the tail. And that's all we have defined. So we go ahead and save that, and we come over to the command line. And I call this file traits as interfaces. So we say Scala CLI traits as interfaces, and go ahead and run that. And it's the first time I ran this today, so you see it had to do a little setup work, and then we have the results here. So this is an initial look at how to use traits as pure interfaces. And in the next page of my book, I start getting into the initial benefits of using traits as interfaces. So if you haven't done this before, I get into this here. And one of the big benefits of using interfaces rather than just concrete classes is that it makes your code more flexible. And basically what happens is that you want people to write to the API of your interfaces rather than the API of your concrete classes, as I note here. And what I can do is show this. Let's just go ahead and copy that. And what I'm going to do is paste that in here. I want to comment that out. And let me do this real quick. So if we didn't know what we were doing, we would say, what if say something took in a dog and it took in the type dog? Then this would say dog.speak. Okay, and then we could come down here and just to add a little separation. Then we could pass in a dog like that and to say something. And this code should work unless I made any mistakes. It's all fine. So this is a function. It's named say something. It takes an input parameter, which has the type dog. And then inside here, I call the speak method on that dog. And the speak method exists right here, which it extends from this trait right here. So this should work just fine. So I'll go ahead and save that. Come back over here. And now we should run that and see that output again. And we do indeed get another woof right there. And the issue with this is that it's not very flexible. So as our code grows, and we say, well, now that we have a dog, seems like we should also have a cat, right? So now we have a cat, and you'll notice when you look at this code, you'll say, these two methods are exactly the same as these two methods. So there's kind of a code smell there, and I'll worry about that more in the next lesson. The part I want to fix right here is this, because the cat doesn't say woof, it says meow. And now we get into the problem with this method, is if we didn't know anything about interfaces, we would say, well, what I need to do here is change this, and apparently this one needs to be cat, and then we have cat.speak. But of course the issue is with this is we're duplicating codes. We have a dog and a cat, and we're dealing with these types specifically. What's really going on is that the speak method is defined at a higher level, so it's defined in this trait. And what we want to do right here is say, well, since we're calling speak, and that's the only thing we're doing over here, and this function just totally relies on the speak method, it doesn't rely on something like start tail and stop tail. What this should do is take in what I showed previously is something like a speaker, and then the can speak type. And so once we have that, we can delete that. Now we can get rid of that commented out code. And now this code works at a higher level. So instead of taking in dog and cat, it takes in the can speak trait, or anything that implements the can speak trait is what I should say right there. And then we call speak on it. Because of that, we can now say, well, val c equals cat. And then we down here, we can say, well, say something for the dog, and then the cat can also say something. So now when I save that and come back over here, we see that. So now we have woof and followed by meow. So as your code grows and grows, this code like this becomes a huge benefit, because now in this area right here, we are programming to the can speak interface rather than specific implementations like dog and cat. And that makes this function more flexible. So as more and more things implement can speak trait, this function will work for everything that does implement that trait. Getting back to the book real quick, that's what I talk about in this section here. And one of the other things I mentioned down here in the bottom is that not only can you use traits in this area here as types, and I should be very clear, in this case, we're using a trait as a type. So this is just like a type, just like an int or a string or a person or any other type. A trait is just like a type right there. And we can also use it as a type when we specify the return type of a function like this other one. And that's a really important point, that traits work as types. And because I'm only using traits as pure interfaces in this lesson, that'll be the end of this lesson. And then the next lesson, we'll get into traits that have concrete behaviors as well. And as a little bit of bonus for this lesson, there were two other things I wanted to show. So the first thing was, in this lesson, I showed how to start with traits and then how to define classes that extend or mix in those traits. And here I actually just showed extends. I didn't really talk about the mixing in part, so we'll talk about that more in future lessons. But there's also another way that this code can work, and that goes like this. So let me clean things up a little bit here. And so what I am thinking is there's another pattern in programming. And for some people, this is more common, especially when you think about the thought model of doing the simplest possible thing that you can. So when you start to model a dog, what you'll think in your mind might be, well, a dog has a tail. So what I'm going to do, cheat a little bit here, so let me do that. So your thought process is, well, a dog has a tail, so I'm going to write a start tail method for a dog. And then you go, well, since the tail can start, maybe I should also write a method so it can stop. And so then you finish with the tail, and then you say, well, what else can a dog do? And you say, well, of course it can speak. So then you write a speak method. And that's the simplest thing that can possibly work. And then you start writing a cat class. And then you think, well, basically a cat can do all these same things, right? So I will just take all that code and I'll change that to a cat like that. And then the only difference here is you come down here and you say, well, a cat would say meow instead of woof. So you just change that. And ignoring this duplication of code right here and right here, in object-oriented programming, there's a very well-known refactoring pattern that's called extract interface. So that's what we're going to do now, is extract an interface or two here. And we see this common behavior. And so we have start tail and stop tail. We're like, we've duplicated that code here and here. So maybe what we really need here is an interface. So we say trait, and now we have to give that a name. So we say, well, how about you could call it tail or has tail, is what I used before. So we'll say has tail. And it's going to have these two functions here. And they both return unit. And since we're only talking about abstract methods here, then that's going to be our interface for the tail. And now we can say, well, class dog extends has tail, and then class cat extends has tail. And again, there's some duplication of code here and here, and we're going to take care of that in the next lesson. But for right now, we're just going to move these two methods up here. And then we see that we have a speak method in common between those two. So again, we would say trait can speak. And that's going to have a method, and it's going to be def speak with no input parameters, and it returns unit. And then we say this. So can speak and can speak. So again, this pattern is called extract interface. So we were looking at this code here and here. We saw a duplication, so we pull that out as a trait up there, and then we do the same thing here. And then if you would like a preview of the next lesson, really all that involves, right now these two are abstract methods right here, and the only thing you have to do to make them concrete is to copy that right there, put that there, and actually I'm not copying, but I'm cutting. And the reason I'm cutting is because, stand by, actually that one I want to leave abstract. Now, once those are concrete methods, we can do that. And so this part is what we're going to get into in the next lesson, is that traits can have concrete members. And a concrete member is just a member that has a method body over here like that. So I just wanted to show you that because we did have this duplication of code. And this shows another benefit of traits is that you can pull common behavior like these out into an interface or a trait. And then the dog class and the cat class both get that behavior by extending or mixing in that trait. But for this lesson, I'll need to go backwards a little bit. And in terms of this lesson, this is where I would leave this code. And then the other thing I wanted to show was this image here. So this is for people who might be a little more visually oriented. So I will just move that one right there. And this just shows kind of using the Unified Modeling Language, UML. This is our dog class here. And our dog class extends both has tail and can speak. Using the tool that I'm using, it shows an I for the interfaces has tail and can speak. But in our world, those interfaces are traits. And I'll also explain the term trait more as we go along, why we use trait instead of interface. But again, just for people who are more visually oriented, I wanted to show how this works. So again, the dog class seems to extend these two traits, and both speak over here and start tail and stop tail have the unit return type. So that's why I show those like that. So these are a couple of bonus things I wanted to add to this lesson real quick.